Look in the mirror. Now look at this chimpanzee. The difference between you and this face is smaller than 2% of DNA. Of course, you might say, we evolved from monkeys. Wrong. They're not our ancestors. They're our evolutionary cousins. About 6 to 7 million years ago, one population split in two. One of the closest known candidates for that common ancestor is a species called Sahelanthropus chidensis. Possible, the first monkey to walk on two legs. But what truly surprised scientists, it wasn't found in America or Europe. It was discovered in the heart of Central Africa, in the deserts of Chad, where even modern humans struggle to survive. Which means our story didn't begin in a single Garden of Eden. It began in a harsh, ancient landscape we're only starting to understand. Just like us, modern animals look cleaner, safer, more familiar. But that's only because you're seeing the latest versions of the lineages that once ruled the planet. And if you still think modern animals are cute and safe, give me a few minutes. I'll fix that. The chicken looks great on the table and on logos. Funny, cute, a little goofy, but that's the surface. Because to the creatures she actually hunts, worms, beetles, caterpillars, she's a fast, precise predator. And the reason she can track prey like that? A chicken sees movement more than twice as fast as a human. To us, the world is smooth. To a chicken, everything flickers like a broken strobe light. Wave your hand. You see a blur. A chicken sees every micro motion one by one. That's why they look so jumpy. Their brains run reality in fast forward. And yet, with all that visual superpower, this is still the bird that can lose a fight to a strong gust of wind. But here's the turn. The chicken is just the gentle, harmless final patch of a family line that used to be a completely different story. Now meet Deinonychus. Deinonychus was the one they should have put in the movie. About 11 feet long, weighing 150 to 200 pounds, with a 5-inch sickle-shaped claw on each foot, a built-in cutter for gripping, slicing, and pinning prey in mid-air. Its claws were deadly not because of brute force, but because all the power of its kick focused into a razor-sharp point. One strike could drive that claw through hide and muscle in a single motion. It had forward-facing eyes with real binocular vision, depth perception like a hawk's. Its stiff tail worked as a balancing rod, letting it sprint, leap, and whip around corners without losing control. Its jaws were fast. Grab first, ask questions never. Models suggest it could strike in under 70 milliseconds, faster than a human blink. And the unsettling part? There's evidence they may have hunted together. Coordinated groups of prehistoric super chickens with knives for feet. Tenontosaurus fossils covered in deep slashes? Most likely them. And here's the part that genuinely hurts to imagine. Deinonychus could jump more than 10 feet in a single bound. So if a chicken ever gives you a weird look, don't test your luck. Did you know that scorpions can withstand radiation levels 100 times higher than those lethal to humans? And that spiders move using hydraulics? Now imagine a creepy hybrid of a spider and a scorpion and magnify it 50 times. Pulmonoscorpius. A scorpion-like arachnid nearly 2.5 feet long, a size that feels wrong for something with so many legs. And no, this wasn't a giant spider. This was a time when spiders and scorpions hadn't fully split into separate groups yet. Early arachnids were experimenting. Thick armor, massive claws, primitive lung structures, limb systems still taking shape. And the fossils capture that transition clearly. The Scottish specimens show heavy armor plating across the body, not delicate spider cuticle. This thing wasn't soft. It was a walking shield. Its pincers didn't grab, they crushed, strong enough to break the chitin shells of giant Paleozoic insects. And its prey wasn't small. Pulmonoscorpius hunted prehistoric insects, long as a modern smartphone. Early amphibians like juvenile Crassigyrinus lurking near the waterline, and other armored arthropods that wandered too close. anything roughly its size could end up as dinner. It lived about 340 million years ago in swamp forests where humidity, dim light, and oversized arthropods shaped the rules of survival. Its eyes were tuned for movement in that greenish gloom. It breathed using early book lungs, stacks of thin plates that worked like a biological radiator for oxygen. And the important part, before vertebrates ever tried being top predators on land, creatures like Pulmonoscorpius already held the job. So if a modern spider looks cute and harmless to you, just remember, its ancestors shaped the rules of those swamps long before vertebrates appeared. Take a deep breath, relax. Feel the oxygen filling your lungs? And now, can you imagine a creature that doesn't need lungs or gills to do this? Its skin absorbs oxygen straight from the air and the wet ground, a walking sponge with a heartbeat. You're looking at a salamander, soft, tiny, quiet. But here's what you don't see. At night, when the forest gets damp enough, it slips out of the undergrowth like a living drop of water. No sound, no footsteps, harmless, timid, barely noticeable. And yet, this shy little amphibian has a family history that does not match its energy because its ancestor wasn't cute. It was colossal, Prionosuchus. Imagine a salamander stretched to the length of a city bus, up to 26 feet. Its skull alone reached 5 feet, longer than a home bathtub. Evolution didn't just scale it up, it turned it into something that ruled the rivers of the Permian. 270 million years ago, when tropical swamps covered South America, Prionosuchus lurked beneath the surface. It looked like a mix between a salamander and a crocodile, except Prionosuchus didn't pretend to be calm. It waited motionless for minutes, then exploded forward with a strike powerful enough to drag down anything in reach. Modern salamanders nibble insects. Prionosuchus reshaped entire river ecosystems the moment it entered the water. Its jaws held rows of long, needle-sharp teeth built to grab slippery prey. Large fish, early tetrapods, juvenile temnospondyls. Any creature unlucky enough to drift too close. Its size alone makes it one of the largest amphibians ever found. Not just big, but an apex aquatic predator living in the same kind of rivers where you casually throw stones today, just to watch them splash. So if salamanders look harmless to you, remember their ancestor decided who left those swamps alive. It's good to be smart, right? But imagine having not one brain, 8. That's the octopus. And before you even notice it, it has already escaped, attacked, or solved the problem you didn't know existed. A clam snaps shut on the seafloor. Safe, right? Wrong. One octopus arm slips in, not through an opening, but between the shell plates, finding a microscopic gap by touch alone. The arm tastes, analyzes, decides. Then the rest of the octopus pours in like liquid, and the shell stops mattering entirely. That's the modern octopus. 3 hearts pumping blue blood, 8 arms acting like independent brains, skin that changes color and texture faster than a camera shutter, a body that fits through spaces smaller than its own eyeball. And if this soft, flexible creature is the gentle version, what did its ancestors look like? Orthoceras. No flexibility, no squeezing through cracks. This ancestor was a straight-shelled predator over 10 feet long, a rigid, armored spear moving through ancient seas. Its eyes were surprisingly advanced, built for the dim, hazy Paleozoic waters. And it didn't swim alone. Fossil beds in Morocco reveal clusters of these shells, dozens or even hundreds drifting and hunting together. But the detail that changes everything? That long, rigid shell worked as an underwater hull. When Orthoceras fired its jets, it didn't curl or twist. It blasted forward like a pressurized dart ripping through the water. Inside the shell, chamber after chamber filled with gas acted like built-in ballast tanks. One adjustment, and Orthoceras rose or sank like a biological submarine. From the open end extended a muscular body with grasping, tentacle-like arms ready to seize anything drifting too close. Modern octopuses survive by being liquid. Orthoceras survived by being a spear. Same family, opposite physics. Before you ever see a dragonfly sitting quietly by the water, it's already finished the kind of hunt you'd never expect from something this small. Imagine 10 flies hovering over a pond. The dragonfly spots them from more than 30 feet away, adjusts its angle for a split second, and then it's over. 9 out of 10 are gone before you'd even register the movement. That 90% accuracy isn't luck. It's a visual system that covers almost the entire head and reacts to motion faster than a human can process light. And that's the modern version, which raises a simple question. If today's dragonfly is already this good at killing, what did it inherit from its prehistoric relatives? 300 million years ago, long before birds or dinosaurs, Meganeura dominated the Carboniferous skies. Oxygen levels were higher, trees reached around 150 feet, and insects grew into forms that look unreal today. The world was ruled by giant insects, early amphibians, and the earliest reptile-like creatures. Meganeura was a dragonfly pushed into a size category no one would want flying past their face. A 28-inch wingspan, about as wide as a car tire. We know this thanks to exceptionally preserved fossils. The wings found in the coal deposits of central France show every vein as if they were pressed into the rock recently. Meganeura filled the role that predatory birds fill now. It patrolled above the fern canopy and struck from above with sudden, sharp dives. It didn't hover politely. Meganeura made sharp turns, sudden drops, and fast strikes. More like a flying hunter than an oversized insect. Its eyes were larger than those of some modern small birds, built to detect movement in the dim, filtered light of ancient swamp forests. And it didn't bother with flies. Those weren't even worth noticing. Its targets and rivals were the same. Anything big enough to be a threat or a meal. Meganeura hunted large insects, palm-sized armored roaches, and even amphibians that came too close to the water. So the dragonfly you see today is just a small, quiet reminder of a predator for which the air itself was territory. And what do you know about a body built to kill? Yes, you heard that right. One twist, one flick, and the pressure shock from a penguin's dive hits the prey before the penguin itself does. That's how precise and controlled this bird is underwater. But even that isn't the impressive part. Because the penguin you know, small, rounded, cute, is just the final, softened version of a lineage that once played by very different rules. Icadyptes. A penguin that stood nearly 5 feet tall and, plot twist, lives not in ice but in tropical heat. Ancient Peru, 86 degrees Fahrenheit seas, 0 snow, 0 ice. The entire stereotype collapses right there. Its bones were exceptionally dense, letting it dive fast without fighting buoyancy. But its main weapon wasn't the dive, it was the beak. A long, rigid spear of bone, 8 to 10 inches of pure offense, the longest beak, proportionally, of any penguin ever found. Fossils show that this beak could punch through thick scales and bony fish armor. And that spear sat on a long, flexible neck, far longer than in modern penguins. That combination turned Icadyptes into a feathered harpoon. And now, attention. Icadyptes wasn't just a predator, it was competition for sharks. In the Eocene seas, smaller shark species actively avoided the hunting zones of giant penguins because the penguins hit harder, faster, and with better aim. So when you see a penguin waddling around, you're seeing the tiny remnant of a bird that once forced sharks to adjust their routes. So today we learned about some of the most fascinating ancestors of modern creatures, those that once ruled their world. But would you like to learn about the latest discoveries and today's modern dinosaurs too? Let me know in the comments, and don't forget to like and subscribe. See you in the DinoVerse!